here to announce this Dell AI Factory with Nvidia going to market.
On the stock, the highest price target for Nvidia over the last several weeks.
We've re-engineered and reinvented every layer of computing.
Welcome to GTC.
Could the Dell and Nvidia partnership be unleashing something terrifying for humankind? Michael Dell says they're using their tech smarts to revolutionize factories, making it easy for any business to start massive projects fast and cheap. They're pushing the limits, combining Dell's hardware with Nvidia's AI to transform industries like healthcare and manufacturing. Let's explore the hidden dangers awaiting us in this dangerous move. Pioneering the future of smart factories, the Dell-Nvidia collaboration, explained by Michael Dell, is similar to Dell's earlier simplification of personal computers. They are now applying the same method to these advanced factories. Any company can now approach Intel with specific needs or designs and quickly begin large-scale production. This is a big advancement, enabling the creation of large-scale intelligent systems and opening up new possibilities for technology and innovation. This step also allows companies of all sizes to access cutting-edge technology without needing a huge budget or technical expertise. By streamlining the setup, Dell and Nvidia are making advanced systems more accessible. Manufacturing is now easier than ever, potentially changing how industries operate, making them more efficient and innovative. Here's something even more exciting. This collaboration is not just about simplifying processes, but pushing the limits of what is possible. By combining Dell's hardware expertise with Nvidia's skills in graphics and artificial intelligence, they are creating a powerhouse that could drive significant advancements in various fields, whether in manufacturing, healthcare, or other sectors. This partnership promises to bring major improvements, but the real game changer is how this collaboration is setting new industry standards. By combining the best of both worlds, strong hardware solutions and advanced AI technology from Nvidia, companies can now achieve unprecedented levels of performance and efficiency. This collaboration isn't just a step forward, it's a huge leap that redefines the future of smart manufacturing and innovation. Nvidia's total cost of ownership is so low that even if competitors offered their chips for free, it would still not be cheaper. Over the last decade, Nvidia has made computing and artificial intelligence much easier to use, making learning much more affordable. This drastic reduction in cost enables extraordinary uses of computing power. For example, imagine using this power to access all human knowledge online, capturing every bit of information from the internet, and allowing a computer to analyze and understand all that data. It's a bold idea. Let a single computer process and comprehend all the internet's data. This is possible because the cost of computing is nearing zero. With this advancement, Nvidia has created a new way of developing software that even beginners in AI can appreciate. Nvidia has learned to make computers not just see patterns, but also understand their meanings. Think about genetic sequencing. It turns biological genes into digital data. Thanks to large language models, we can now understand what these genes do. You can determine the function of a cell as if interpreting a page of text. This is revolutionary because it turns complex biological data into a story that a computer can read and summarize. But this is not the end of the story. Nvidia is about to enable continuous learning, where AI training and application become ongoing and constant. The cycle of learning and application will mirror human learning, continuous and integrated with real-world data, both real and generated by the computer itself. Regarding hardware, Nvidia's top GPU, the H100, will soon be followed by the H200, with plans to expand this technology yearly. By 2029, Nvidia might introduce the H700, further enhancing capabilities. Moreover, these chips are not small. One chip weighs 31 kilograms and includes thousands of parts, but it can replace entire data centers. The cost might seem high, $250,000 per chip, but when considering the savings in data center operations, the investment proves worthwhile. This single chip significantly reduces operational costs and increases computational efficiency to levels previously unimaginable. But that's not all. As Nvidia continues to lower the cost of computing to nearly zero, the possibilities for use increase. It's like lower transportation costs making travel easier and more accessible. Just as cheaper travel encourages more travel, lower computing costs will encourage more complex computing tasks. This shift will change how we solve problems and innovate, making projects that previously seemed impossible now feasible and affordable. It's not just about technical capabilities, it's about changing how we interact with digital information. The potential to revolutionize industries like drug discovery is vast. It can help us understand complex data and interactions within biology. It's not just about reading a PDF, it's about grasping the essence of research, capturing the details of scientific breakthroughs as if talking directly with the researchers. Deep understanding of data's meaning, enabled by advanced computing, will be one of the most significant advancements of our time. But the true potential of this innovation extends beyond immediate applications. Jensen Huang envisions a future where AI and advanced computing profoundly shape our world. Let's see how Nvidia is changing the way we use technology today. From graphics to grand discoveries. Let's talk about how technology, especially from Nvidia, is changing our daily lives in a big way. It's more than just small improvements. It's a whole new way of seeing and using tech. Nvidia started with gaming and grew way beyond that. Back in the early 2000s, Nvidia was all about making graphics hardware for games. They made graphics cards to help the main computer processor, the CPU, with tough tasks. But as these graphics processing units got better, engineers saw they could do much more than just make games look good. They found out that GPUs could be used for other things like data analysis and scientific research. This idea led Nvidia to create the general-purpose GPU. So GPUs weren't just for graphics anymore. They could handle many different tasks. But switching from just graphics to other tasks wasn't easy. At first, using a GPU for something besides graphics was like asking an artist to do complex science experiments, really hard and confusing. In 2007, Nvidia made a big breakthrough with something called CUDA. CUDA made it much easier for developers to program GPUs. It allowed them to write code for GPUs in a way they were used to, opening up many new possibilities. This was crucial because it made GPUs accessible for general programming. But this wasn't the end of the story. The growth of CUDA is tied closely with the rise of deep learning. Neural networks, which are part of AI, process information layer by layer, and GPUs are great at handling these tasks all at once, speeding things up a lot. Interestingly, the operations in computer graphics like matrix and vector multiplications are similar to what's needed in neural networks. By 2010, GPUs were excellent for general tasks, especially in training AI algorithms. But that's not all. In 2012, a team including Jeffrey Hinton, Ilya Sutskever, and Alex Krzyzewski used several GPUs to train a neural network called AlexNet. They entered it in an image recognition contest and outperformed everyone else using traditional methods. This event is often seen as the start of the deep learning revolution. The key to AlexNet's success was using GPUs to speed up training, allowing the team to work with larger networks and more data much faster. This highlighted how vital GPUs were for advancing deep learning and marked a turning point in recognizing the potential of neural network technology. From then on, the combination of deep learning and GPU tech sparked a technological revolution, driving innovation in many fields and leading to new discoveries in AI. In the early 2000s, Nvidia focused on creating hardware for real-time computer graphics, mainly for gaming. Graphics cards helped the CPU manage heavy workloads. But as GPUs got better, engineers realized they could do more than make games look good. They saw that GPUs could handle tasks like cryptography, data analysis, scientific simulations, and deep learning. But this change wasn't easy. At first, using a GPU for something other than graphics meant translating your code into something the GPU could understand. It was like asking a painter to do complicated scientific experiments, a tough and confusing job. Now let's look at how Nvidia keeps pushing the limits with new technology. The real-world impact of Jensens Law on AI. In 2007, Nvidia made a big leap with CUDA, making it much easier for developers to program GPUs. CUDA allowed programmers to write code for GPUs in a way they were used to, opening up many new possibilities. This was crucial because it made the complex language of GPUs more accessible for general programming. But that wasn't the whole story. A few years ago, Jensen Huang, Nvidia's CEO, introduced Jensens Law. Similar to Moore's Law, which predicted that the number of transistors on a chip would double every 2 years, Jensens Law focuses on GPUs. It predicts that their performance will double every year. This is interesting because while Moore's Law is hitting physical limits, GPUs keep improving through new optimization techniques and better designs, especially in AI. In 2019, Nvidia's progress was incredible. Servers with K80 GPUs used to need 600 hours to train a model like ResNet 50. By 2019, it took only 2 hours, a 30-fold improvement in 5 years, doubling performance each year. But this wasn't the worst part. In the last 2 years, there have been even more significant advances with the rise of generative AI and large language models. For example, it was estimated that training GPT-4 required around 25,000 Nvidia A100 chips for 90 to 100 days. With the newer H100 chips, the same training would take only about 8,192 H100s, halving the time. This huge reduction in time and cost explains why in 2023, many Silicon Valley companies are eager to get Nvidia's chips. Access to A100 and H100 GPUs has become the new currency. There's talk of GPU-rich tech companies with vast resources and GPU-poor startups with limited access. It's worrying to see this gap growing. For example, Meta announced it would have 350,000 H100 GPUs by the end of 2024, which combined with its infrastructure would give them the power equivalent to 600,000 H100s. Meanwhile, consumer hardware is also adapting to this new era of AI. Consumer graphics cards are also changing, keeping up with the demand for more power in AI tasks. They've been working hard on improving the tensor cores and making the memory inside these cores better. Tensor cores are special because they help with fast calculations that are super important for making deep learning tasks quicker. The memory in these cores has also been getting bigger and better over the years. But this isn't the end of the story. There's a lot more to come. In the future, we can expect to see more open source models that are even better than what we have now. People will want to use these models on their own computers, which means they'll need powerful graphics cards. One example of how this technology is used is in something called DLSS. DLSS uses AI to make gaming images look better and reduces the work the graphics card has to do. This lets the graphics card focus on tougher tasks. It's just one of the ways AI is changing not just science and industry, but how we interact with technology every day. This is leading us into a new era where how well AI works is going to be really important. Next, we explore how Nvidia is blending AI with fast computing, change the game, navigating the new currents of computational power. Nvidia's Accelerated AI. Next, let's talk about how Nvidia's AI technology is changing computing and AI. Nvidia is diving deep into accelerated AI, which combines fast computing and artificial intelligence in a system called the Omniverse. This technology is set to shake up the whole computing world, which has been around for over 60 years. A lot of the basic tech we use today started in 1964, just after the IBM System 360 came out. It introduced things like the central processing unit, the ability to do many tasks at once, and the separation of hardware and software. These big ideas helped make computers something everyone could use, starting with personal computers and then smartphones like the iPhone in 2007. Since then, we've moved to a time where being connected to the cloud from our mobile devices is normal. In the last 60 years, computing has changed a lot, but now it's on the verge of another big change. The CPU, which has been super important, is not getting faster as quickly as before, while we still need more and more power from our computers. This mismatch is creating a situation called computational inflation, where the cost of computing goes up as the energy used by data centers around the world increases. Nvidia has been a leader in accelerated computing for nearly 20 years to tackle these challenges. The idea is simple but smart. Move and speed up tasks to specialized processors, like GPUs that can do them better than CPUs. The results have been really impressive, showing that speeding up all possible tasks, especially in data centers, is a good move. For instance, tasks that used to take 100 units of time can now be done in just 1 unit of time with this tech. The benefits are huge: a performance boost by 100 times, while only using 3 times more energy and increasing costs by about 50%. In practical terms, adding a $500 GPU to a $1,000 PC can really boost its performance. This speed up isn't just for usual computing tasks. It also helps with more complex algorithms used in deep learning, computer graphics, physical simulations, and more. These tasks are perfect for something called parallel processing, which GPUs are really good at. To help with this, Nvidia developed CUDA, a platform that makes CPUs work better with GPU speedup, handling everything from AI and physics to telecommunications, and even quantum computing simulations. One of the coolest uses of this tech is creating digital twins, like Nvidia's Earth 2 project, which aims to simulate Earth to predict and prepare for climate impacts. This project and others like it use the huge power of accelerated computing to do things we once couldn't imagine. Looking ahead, the potential for accelerated computing keeps growing. It's likely that all data centers will use this tech, which will cut down the time and cost needed to process large amounts of data. This shift isn't just about being more efficient, but also about reaching amazing levels of computational power that will change what we can do with technology. As we move into the era of generative AI, which can create content from text to images and more, the impact of these technologies grows even bigger. AI is starting to change how we interact with machines. It's no longer just about telling a computer what to do, but about interacting with a system that understands and anticipates what we need. Let's dive into how NVIDIA's innovations are shaping the future of tech. The birth of NVIDIA's token factory. In this time of rapid change, continuous innovation in accelerated computing and AI is not just making things more efficient, but is also setting the stage for the next wave of tech advancements. It's not just a change, it's a complete overhaul of how we think about and use technology. In the world of technology, a major shift is happening. It started with a supercomputer and has now become something much bigger, a dedicated AI data center. Jensen Huang explains that this isn't just any data center, it's an artificial intelligence factory, and its main product is something called tokens. To understand NVIDIA's vision for the future, it's important to know why this AI factory exists. It's very special. It's not about producing common products, but about creating a new and highly valuable product. Tokens. These tokens are to the digital economy what electricity was to the industrial era. Just as Nikola Tesla's invention of the AC generator changed the world by generating electricity, NVIDIA's AI generator is creating tokens. Both inventions opened up huge market opportunities, marking a new industrial revolution. All industries can use these tokens, making them very useful and applicable in many different fields. Imagine an AI factory operating like a traditional factory. The technology industry is changing like never before, especially in the field of artificial intelligence. Traditionally, the IT market was worth about $3 trillion, but now it's expected to reach $100 trillion. This huge shift is because of how we use computers. They used to be mainly for storing and processing data. Now they're developing intelligence that can be used in all kinds of industries. This new era is marked by computer-generated intelligence, which is a big change from past practices. Accelerated computing has evolved into AI, and more recently, into generative AI, starting a new industrial revolution. The impact of this revolution is vast. It has the potential to introduce completely new products like tokens, which can be customized for different uses. This change also includes a complete overhaul of computer architecture from CPUs to GPUs. Now, computing focuses less on retrieving data and more on dynamically generating content, improving the relevance and speed of data retrieval. NVIDIA has introduced NIMs as key components of this new era. NIMs are AI models that can run both in the cloud and locally, offering AI capabilities without needing a complex infrastructure. They can handle everything from language processing to advanced data analysis and are designed to work on multiple GPUs at the same time. But this isn't the most challenging part. Nvidia has made this complex integration simpler with its AI-in-a-box product, which includes tools like CUDA and TensorRT. These are hosted in cloud-native containers that can automatically scale, making AI implementation quick and effective. Nvidia has continued to lead in developing digital humans, AI-powered entities that can act as customer service agents or brand ambassadors. These digital humans are realistic and can interact in ways that make them seem almost human, crossing the uncanny valley. Thanks for watching. Before you go, what are your thoughts on the ethical implications of AI in decision-making? Leave your comments below and don't forget to subscribe.